Hi everyone. Today we're going to finish our learning about sedimentary rocks. So we're going to need to take out our earth science reference tables to page 7, and we're going to need our note packet. I hate to call it a note packet. We're going to need our rock and mineral packet, I should say. And let's open that to page 15. I believe that's where we have the rest of our sedimentary rock information. So let's start with the earth science reference tables for a minute. Page 7. Now, the part up here, this part right up here, is the clastic rocks we learned about last time. The rocks that are formed from fragments of other rocks, cemented and compacted, or compacted and cemented together. Now, we're going to move on to two of the remaining kinds, which is the chemical or crystalline variety of sedimentary rock. And then finally, we're going to go on to the bioclastic or the organic variety. So let's start with the chemical crystalline. The chemical crystalline forms in a way that we did sort of discuss earlier. And I'm going to go now to a little diagram that I made here to kind of help us out with that. And it's something you don't have, so just kind of bear with me on this. Now, here I have a model of a container of water, let's say. Or let's say it's ocean water, seawater. And in the seawater here, we have dissolved in the water, we have, let's say, dissolved either gypsum or halite or calcite, the mineral of your choice, but it's dissolved in solution in this water. Now what happens is, the water's holding on to these particles. Now eventually, let's say the water happens to evaporate. Now when the water evaporates, we no longer have the water that was holding these dissolved minerals. So where are these dissolved minerals going to go? Well, the answer is they're going to sink to the bottom. The solution can no longer hold them. So it sinks to the bottom and it forms a layer down here. Now, so basically what happens is the evaporation of the water led to the precipitation of the minerals. And that's how we get these chemical or crystalline rocks forming down there. So remember, evaporation leads to precipitation. So remember, these chemical precipitates form from the evaporation of the seawater. Now let's take just a quick look at the ESRT and learn a little bit about this. We identify the rock by the minerals that make up the rock. It's called the mineral composition. So if the mineral making up the rock is halite, the rock is going to be known as rock salt, and that checkerboard formation is the symbol for rock salt. If the mineral making up the rock is gypsum, or I should say if the mineral that precipitated out of the solution was gypsum, it forms rock gypsum. And if the mineral that precipitated out of the seawater was dolomite, it produces a rock called dolostone. And there is one more. Calcite can be crystalline as well. So if the mineral that precipitates out of the ocean happens to be calcite, it'll form what we call chemical limestone. But there are other varieties of limestone as well. So I'm going to put this kind of halfway right there. Okay, so let's carry this information now to page 15. Let's take a look at our table here on the chemical or crystalline sedimentary rocks. So the chemical or crystalline rocks form from the evaporation of water and the precipitation of dissolved minerals. So remember, evaporation leads to, please put your answer right there for an easy point. And your answer is evaporation leads to precipitation. Now let's compare to the earth science reference tables. If the mineral composition happens to be calcite, the rock formed is going to be what? Well, the rock formed is going to be chemical limestone. I'm only going to require that you put limestone. Okay, let's work it the other way now. If the rock formed is rock salt, what was the mineral that made up that rock salt? Please put your answer there. The answer is the mineral was halite. If the mineral was gypsum, the rock formed was rock gypsum. And if the rock that formed was dolostone, what was the mineral that precipitated to form it? The answer is dolomite. And these are the symbols for these rocks. Dolostone symbol kind of resembles calcite symbol, except it has sort of like a lean to it. All right, which is interesting because both of those two will react with acid, but dolostone has to be powdered. Okay, now based on what we just did, this should not be a problem for you. Chemical or crystalline rocks are identified by the blank composition. The what composition? Please put your answer right there. Okay, I hope you didn't say chemical composition. The answer is mineral composition. Right, looking good, people. Now, let's take a look at the next type of igneous rock. I'm sorry, sedimentary rock we're going to look at. Why do I keep doing that? Now we have the organic, also called bioclastic variety. Now, organic means that it was derived in some way from a living thing. And that's what these are. So we have two that we have in the ESRT. One is bituminous coal. Coal forms from millions and millions of years of plant matter that's been packed tighter and tighter and tighter and compressed. Now, about 300 million years ago, we had tremendously vast forests on Earth, tropical rainforests, vast, covering thousands and thousands and thousands of miles. And they existed for millions of years, maybe 100 million years. And that's a lot of plant matter to be accumulating. And that plant matter accumulates, the dead plants accumulate, they get pressed tighter and tighter, and eventually form coal. But we also have a variety of limestone that's organic. And this limestone is sometimes called fossil limestone, and it comes from shell fragments that have sank to the bottom and been compressed at the bottom of the water. So that's a fossil limestone. So let's return to our rock and mineral packet, and let's organize the information that we just learned. So your organic or your bioclastic rocks, they form from the accumulation and compaction of plant or animal matter, which eventually becomes rock. So let's answer these. Which one has a symbol like this and is made from cemented shell fragments? I'll give you a hint. The shell fragments were originally calcite. So what is that rock? And your answer is, that rock was fossil limestone. And millions and millions of years of compacted plant matter, that's the symbol for it. What is that rock formed? ESRT will tell you. And the answer is, it's coal. Now, a little quick rundown on how the coal forms. We have a little diagram to help us with this. So we have millions and millions of years of compacted plant matter here, which just accumulates and accumulates. Now the plants die, and the plant matter of the dead plant eventually gets pressed tighter and tighter and tighter over time as the accumulation and the weight above it gets greater and greater. Now what happens is that rock eventually becomes denser, harder, blacker, and shinier. And that's what eventually happens, and then it finally becomes coal. So over the course of these millions of years, the compressed plant matter becomes darker, it becomes denser, and it becomes shinier. And it eventually winds up being the bituminous coal that is used as a fuel. Okay, now everyone, I think we're done with this one. Thanks for paying really close attention, and we're going to leave any questions at the end, okay? I'll have another one tomorrow. Good night.